Hello. Hello, my name is Yücel Uysal and I am working at Dow Science Academy, Tals High School. So I am a physics teacher and engineering teacher for the 9, 10 and 11 grades. And today we're gonna make an engineering lesson. It's take approximately 5 days. And this is the demonstration about that. And it's included the last part and the most important part. And I'm going to talk about a little bit how our process works. First of all, we have to find a problem, then we should try to solve the problem. So when I come to the United States 2 years ago, I saw the road works is taking too long time. When I come 2 years ago, the road work start in the Dallas and it's continue still, which means it's more than 2 years, and I don't know how many years it's gonna take, and it's really long time to fix something in the United States. So, which means if we make something stronger, it's better. And when I get my CDL and I drive the truck, the interstate, and I saw that it's really big problem. So we have to solve with the changing how to make the bridges, also roads, and it's make really sense. So right now we have the small problem when we are making a bridge. When we are making a bridge, we are using the concrete, asphalt, and steel. So we are making the bridge. But every material has their time to fall. So if we use the iron or steel, there is a chemical process called oxidation. When the iron gets oxidation, the iron oxide has the much larger volume than the iron. So just imagine that we have the concrete. Inside the concrete, we have a steel. And in a time, when it's get the rain and get the oxidation, it's enlarged. And the inner force just start to break the bridge without out force, even the inner force. And it's take really long time, maybe 100 years, but it's a problem. So our project is using some another materials over steel. So one of them is the carbon fiber. We can use fiberglass. And why we are using the carbon fiber? Because its durability, strength, and the lightweight, and it's also not expensive. So it's water resistance and tensile. So we have many things. Today, just I am passing this part because this is the really long presentation. And here, before coming here, how can we use the carbon fiber or glass fiber inside the concrete? So normally we have materials. As you see, this is the glass fiber, and this is so soft. And how can we use this one inside the concrete? First of all, we make it a little bit harder using some glue, kind of glue. We call it epoxy here. As you see, this is our epoxy and hardener. And before the starting, I want to not mess up with my environment, the table. So I used a sheet of plastic here, as you see, and I just tape it to not move. Then I can make my project easily. It's kind of composite. And when it's ready, as you see, first of all, we have to prepare our materials, epoxy. And my epoxy needs the half hardener and half epoxy. So just I have to mix them up. So get the plastic cup, put half epoxy. This, the high viscosity, as you see, and half hardener here. So mix them up very well. So then we can use it in our project. First of all, we have to separate all over our plastic sheet on it, as you see. Just easily we can separate around, because we want the fiberglass sheet stick on it. So it is a simple way. So take one of them, put on it, and before the process you should use gloves or you get dirty. Okay, just glue it here and be sure there is no bubble and every part get equal amount of the epoxy. After this process, I am making a little bit faster here, but you can take your time, put more here, and put the second one, and use more epoxy, and we can make it 3 or 4 layer for our project. But we don't have time for the demonstration, then I bring it that before I did here. You can see this is the fiberglass sheet and this is the carbon fiber sheet. You can use both of them or separately, or you can make it different composites. And today I made these 2 of them as a skeleton of the bridge, so I can use it. And I had really short time to build something, so I couldn't use the concrete because the concrete take really long time to dry and test it. Instead of the concrete, I used the plaster, and plaster is the weak. This one has no skeleton, which means there is nothing inside it. There is no steel, there is no carbon fiber or fiberglass. And here, the second one, I used the fiberglass in it, and it's stronger. As you see, this is just 2 pieces, and this is 3 pieces because it breaks suddenly into many pieces. And this is the carbon fiber one. Even after the breaking the plaster, it stays strong because the carbon fiber is really strong material. Just we can make different kind of designs, but end of the story, the students can realize it. This is our test. In this test, this is the without skeleton, without anything, and it can just hold 97 pound load. And this is the fiberglass. Fiberglass hold 141 pound force, and it's the important one. As you see, what about the carbon fibers? How many load it can hold it? Just imagine that this is not the concrete, this is just the plaster, and it's hold 396 pounds. With the carbon fiber, 396. Without carbon fiber, just 97. Approximately this thin carbon fiber make 4 times stronger our concrete. So we can solve in different methods, but this is the one of the way, and it take 5 days, and this is our application. Just make it a different composite, and you can test it. This is our test machine, as you see here. Even without this 97 load, we put some load, which means actually it's more than 97 without anything, or I can say it's more than 97 on carbon fiber 396 more than, because it's already took some weight on it. Thanks.